All right, guys, welcome back. Let's go one more time. Let's take a look at one of these problems that we did forever ago. Something like cosine theta plus tangent theta times sine theta. It's not an equation. I'm just asking you to simplify it. Turn it into something that is simpler than what it currently is. One of our ideas to do that is to turn everything into sine and cosine. So we have cosine theta plus sine theta over cosine theta times sine theta. So we would then have cosine theta plus sine squared theta over cosine theta. We can then make the bottoms the same by multiplying this guy by cosine theta over cosine theta. We get cosine squared theta over cosine theta plus sine squared theta over cosine theta. That puts us at cosine squared theta plus sine squared theta all over cosine theta. And then cosine squared theta plus sine squared theta is simply 1. So I have 1 over cosine theta, which is secant theta. We transformed, we simplified this original guy down to just that. That skill of being able to turn something into something else comes in handy for these next types of problems. So let's look at a problem like this. We're going to have 2 sine x minus cosecant x equals 0. So I can't isolate the trig functions. I have 2 different trig functions. There's nothing to factor. I can't use the quadratic formula. And so I'm thinking maybe it's kind of like the last problem where we square both sides. But even if we squared it, we would end up with a sine squared and a cosecant squared in the same problem. And sine squared and cosecant squared are not related through a Pythagorean identity. So we're a little bit stuck, except maybe we're not. Maybe we can turn one of these into the other. Maybe we can look at this problem differently. How are sine x and cosecant x related? I know that cosecant x is 1 over sine x. So what I'm looking at this point is 2 sine x minus 1 over sine x equals 0. And now I'm just going to simplify. I'm going to just do what the math is asking me to do. That math is asking me to subtract these fractions. So I'm going to multiply this first guy by sine x over sine x. That makes the denominators the same. I have 2 sine squared x minus 1 over sine x. That equals 0. I can multiply both sides by sine x to simplify this down to 2 sine squared x minus 1 equals 0. And from here you can solve using skills that you already have. Pause the video, you work, I'll meet you in a minute. Alright, so continuing on, I'm going to add 1, divide by 2. I get sine squared x equals 1 over 2. Take the square root of both sides, but don't forget to go plus or minus. So I have sine x equals positive rad 1/2 and negative rad 1/2. Cleaning that up just a bit, I have 1 over rad 2 and negative 1 over rad 2. I'm going to look for places where I have an opposite of positive 1 and a hypotenuse of rad 2. So that gives me a 1, 1, square root of 2, a 1, negative 1 in this case, square root of 2. And then I'm also going to look for places where I have an opposite of negative 1 and a hypotenuse of rad 2, an opposite of negative 1, a hypotenuse of rad 2. I end up with these little 45-degree reference angles all the way around. And the spacing looks pretty promising. I know that this is a 90-degree between angles. I know this is a 90-degree between angles. And I know from 45 to 135, we've got little 90s all the way around. So what I end up with is x equals pi over 4 plus pi over 2n. Sometimes at this point people are wondering, well, why didn't you have to check for extraneous solutions? Remember, the extraneous solution thing, that only happens when you solve a problem by squaring the entire problem. And so I don't have to check my answers before I spin around the circle or do anything like that. Now let's see how this problem would have changed if it had been a plus sign in the middle here. We'd have 2 sine x plus cosecant x equals 0. We would still change cosecant to 1 over sine x. All of this math would play out the same, except we would have a 2 sine squared x plus 1 equals 0. And so then we'd go minus 1 divided by 2. We'd have sine squared x equals negative 1/2. Take the square root of both sides, and now I have the square root of a negative. The square root of a negative is imaginary, it's not real, and therefore, what's our solution? There is no solution. So it's the tiniest little change at the very beginning of the problem, but it ended up making a completely different solution. All right, so now try this one and see what you can come up with. Let's go with 4 cosine x minus 3 secant x equals 0. And again, the question that a lot of people have is, when do we know whether to square both sides, and when do we know whether to turn one into the other? And the answer usually lies in the Pythagorean identities. If you can square both sides, and then you have functions that actually relate to each other through a Pythagorean identity, then go for it. That might be the best way to go. But if you can look at it and figure out another way to relate them without having to square it, that's probably the easiest method. Pause the video and see what you come up with, and I'll meet you in a minute. All right, so taking a look, I know that secant is 1 over cosine. So what I have is 4 cosine x minus 3 times 1 over cosine x equals 0. So I have 4 cosine x minus 3 over cosine x equals 0. Multiplying this guy by cosine over cosine, I get 4 cosine squared x minus 3 all over cosine x equals 0. I can multiply both sides by cosine x. That gives me 4 cosine squared x minus 3 equals 0. I'm trying to isolate the trig function now, so I'm going to add 3 and divide by 4. I get cosine squared x equals 3 over 4. When I take the square root of both sides, I have to remember to do the plus or minus. I end up with cosine x equals positive rad 3 over 2 and negative rad 3 over 2. So katoa tells me that we're dealing with the adjacent over the hypotenuse. So I'm looking for an adjacent of positive rad 3, a hypotenuse of 2, that makes a 1, 2 square root of 3, an adjacent again of positive rad 3, but a hypotenuse of 2 could make a negative 1, 2 square root of 3. These are little 30-degree reference angles. And then the adjacent of negative rad 3 compared or combined with the hypotenuse of 2 gives us these two triangles, where again our little reference angles are 30 degrees. So now looking at this, the distance between these two curves, these two angles is 60. The difference between these two is not 60. The difference between those two is 120. And so we are going to have two different solution types. We're going to have this angle. We're going to have this angle and its back-to-back partner. And then we're going to have this angle with its back-to-back partner. So our solutions are going to be x equals, the first green angle is going to be pi over 6 plus the back-to-back half circle situation is going to make pi n. And then we have the red one here. That's going to be 150. That's going to be 5 pi over 6's plus, and again, a half circle situation. It's back-to-back to make a straight line. Makes 5 pi over 6 plus pi n. These are the two solutions. If you have any questions, let me know, and I will see you later. Have a great day. Bye.